NASA just dropped a number that broke the internet. 15 Starship launches. That's what it takes to land humans on the moon. Just once. Sounds insane, right? That's exactly what SpaceX's critics said. Too many launches. Too complicated. Too expensive. They said this plan would never work, but here's what they got wrong. 15 launches at $10 million each. That's $150 million to put 100 tons on the moon. Meanwhile, Blue Origin charges $3.4 billion to send just 20 tons. SpaceX's crazy plan is actually the cheapest moon mission in history. And right now, at Starbase, the hardware to make it real just appeared. Flight 13 is rolling out. New launch pads are rising in Florida. The moon mission isn't coming. It's already starting. Stay with me. This changes everything. Here's the thing nobody expected. On June 22nd, NASA's Office of Inspector General released a report, official document, government paper, IG-2-6-010, not a SpaceX press release, not an Elon Musk tweet, a federal audit. And buried inside that report was a single number that rewrote everything we thought we knew about the moon mission. 15 Starship launches. That's what NASA says it takes just to fuel one moon landing. Not to build the rocket, not to train the astronauts, just to fill the tank. When that number hit the internet, the reaction was immediate. Reddit exploded. Space forums went into meltdown. Critics who had been waiting for SpaceX to fail finally had their moment. See, they said, we told you. Too complicated. Too many launches. This whole plan is a disaster. But here's what they missed. That number isn't a weakness. That number is the entire strategy. And once you understand why SpaceX needs 15 launches, you'll realize this is the most efficient moon plan ever designed by anyone, anywhere, at any point in history. Let me show you exactly how this works, because the math is going to surprise you. First, let's kill a myth. Most people picture a moon mission like this. Build a rocket, put astronauts inside, light the engine, and go. Simple, clean. Apollo did it, right? Wrong. Apollo cheated. The Apollo mission sent tiny capsules with 3 astronauts and almost no cargo. The whole vehicle weighed around 45 tons at launch, and it still required one of the most powerful rockets ever built, the Saturn V, burning every drop of fuel just to escape Earth's gravity. Now look at what SpaceX is trying to do with Starship. The human landing system, the version of Starship designed to actually touch down on the moon, is massive. It carries more crew, it carries real cargo. It's designed to stay on the lunar surface for days, not hours, and it needs to be fully fueled before it ever leaves Earth orbit. Here's the problem. Starship burns liquid methane and liquid oxygen as propellant. The standard Starship upper stage holds around 1,200 tons of propellant. The HLS lunar lander variant is taller, with larger tanks, propellant load closer to 1,500 tons. Either way, that's heavier than a fully loaded Boeing 747 in fuel alone. Several times over. No rocket on Earth can launch that much fuel in a single trip. Not Starship, not SLS, not anything ever built. So SpaceX built a solution that sounds crazy until you think about it for 30 seconds. Instead of launching one giant fuel tank, you launch multiple smaller ones. Send them up one by one, dock in orbit, transfer the fuel, and once the tank is full, send the lander. It's like filling a gas tank with a garden hose instead of a fire hose. Takes more trips, but it gets the job done cheaper than any alternative ever proposed. That's the 15 launch plan. And it's not a bug, it's the feature. The architecture, how it actually works, step by step. Now let's get specific, because the details here are what make this genuinely jaw-dropping. Step 1. The depot. SpaceX launches a specialized Starship configured as a propellant depot. Think of it as a giant floating gas station parked in low Earth orbit. It doesn't go to the moon. It just sits there waiting to be filled. Step 2. The tankers. One by one, SpaceX launches tanker Starships. Each one carries around 150 tons of liquid methane and liquid oxygen up to the depot. Each tanker docks, transfers its load, then returns to Earth to be refueled and flown again. According to NASA's report, this process requires at least 15 tanker flights, 15 separate launches, 15 dockings, 15 fuel transfers, all before a single astronaut ever leaves the ground. Step 3. The lander. Once the depot is full, SpaceX launches the HLS lander, the actual crewed vehicle. It docks with the depot, takes on all that propellant, and only then heads to the moon with full tanks. Now here's the part most people overlook. Those 15 tanker launches use the same rockets, the same ships, the same boosters, fully reusable. Land them, refuel them, fly them again. SpaceX already proved this model with Falcon 9. The same booster flying 20, 25, even 30 times on the same airframe. This isn't 15 rockets. It's a small fleet flying repeatedly, and that single fact changes the entire cost calculation. Let's talk money. Because this is where the critics' argument completely falls apart. SpaceX's target is roughly $10 million per Starship flight. That's what full reusability and mass production are designed to achieve. At $10 million per launch, 15 tanker flights costs $150 million total. Add the lander flight. Call it $160 million for a complete moon landing. With real cargo, extended surface time, and a fully reusable vehicle that comes back and does it again. Now compare that to the competition. Blue Origin's Blue Moon lander is projected at $3.4 billion for a single Artemis mission, and it delivers only around 20 tons to the lunar surface. SpaceX HLS delivers substantially more. But what if SpaceX can't hit $10 million? What if costs stay elevated? Fine. Worst case, $100 million per flight, 10 times the target. That's still $1.6 billion total for the full campaign, less than half of Blue Origin's single mission cost, with more payload and a reusable vehicle. There is no version of this math where SpaceX loses. The 15 launch plan isn't a liability. It's a pricing weapon. NASA knew it when they awarded the contract. The numbers haven't changed. But here's what makes this even more interesting, and almost nobody is talking about it. The hidden problem, boil-off. If 15 launches already sounds like a lot, here's why the real number could be higher. And it has nothing to do with rocket performance. It's called boil-off. Liquid oxygen must stay below minus 183 degrees Celsius to remain liquid. Liquid methane needs to stay below minus 162 degrees Celsius. In the thermal environment of space, maintaining those temperatures is a constant battle against physics. Even with the best insulation available, propellant slowly warms, evaporates, and vents away as gas. Lost forever. You cannot recover it. A well-insulated Starship depot can limit boil-off to around 10% per month. That sounds manageable. But if filling the depot takes 2 months, you've already lost 20% of your propellant before the lander ever docks. That loss has to be compensated with additional tanker flights. The NASA report's 15 flight number almost certainly factors this in. But the physics don't care about the plan. The longer the depot waits in orbit, the worse the loss becomes. This is why launch cadence isn't just a business metric. It's an engineering requirement. SpaceX doesn't just need to launch. They need to launch fast on a tight rhythm, like a factory running a production schedule, not a space program planning a special event. And the second number buried in that NASA report tells you exactly what that factory looks like. The same report that confirmed the 15 launch figure contained a second data point, less dramatic on the surface, but potentially more consequential over time. SpaceX plans to launch Starships from Kennedy Space Center as often as every 8 days. Read that again. Every 8 days. That's 45 Starship launches per year from Florida alone. One location. And SpaceX is simultaneously building at Starbase in Texas, SLC-37 in Florida, and potentially a site at Pecan Island in Louisiana that could eventually exceed everything else combined. Run the moon mission math against that cadence. 2 active pads launching every 8 days fills a lunar depot in roughly 60 days. 1 complete moon mission campaign, first tanker to lander touchdown, in 2 months. The same NASA report flagged something that barely registered in mainstream coverage. That launch cadence will generate approximately 19,000 additional heavy truck trips per year at Kennedy Space Center. Roads and bridges at KSC, many built in the 1960s during the Apollo era, are already in marginal condition. NASA is openly acknowledging its own infrastructure may not keep pace with what SpaceX is building toward. Let that land. NASA is worried its roads can't handle SpaceX's trucks. The agency that put humans on the moon is scrambling to keep up with a private company's logistics operation. That's not a criticism of NASA. That's a precise measure of how fast SpaceX is actually moving. And they're moving fast because they have no choice. The moon mission has a deadline, and the hardware to meet it just appeared at Starbase, in a place nobody expected. The mystery hardware, what appeared on the nose cone. This is where things get genuinely strange. At Starbase, SpaceX has been quietly modifying a Starship nose cone, not building it from scratch, modifying it, adding new hardware in a deliberate step-by-step sequence that tells a very specific story. It started with a bracket, installed near the very top of the nose cone. The position was immediately wrong for anything standard, too high for a crew hatch, too exposed for a routine inspection port. Then SpaceX tack-welded a jig underneath the bracket. A jig is a temporary positioning guide. You use it to place something precisely before committing to the final installation. The jig itself isn't the hardware, it's the setup for the hardware. Days later, the jig was gone. In its place, a short pipe socket fixed to the bracket, and directly beneath that socket, 6 distinct holes in the hull, arranged in a deliberate pattern. 6 holes, 1 pipe socket, top of the nose cone. Here's the most technically consistent interpretation based on available evidence. This has not been confirmed by SpaceX. That pipe socket, roughly 80 centimeters across, is a propellant transfer connection. Too narrow for a crew tunnel. The right size for a fluid transfer line. The 6 surrounding holes are secondary connections, data cables, pressure sensors, thermal management, redundant seals. It's the plumbing interface for orbital refueling. If that reading is correct, SpaceX is fabricating a test article for the single most critical capability in the entire moon mission, propellant transfer between 2 starships in orbit. This is the technology gate everything else depends on. You can build 100 tanker starships. You can maintain an 8-day cadence. You can fill a depot flawlessly on paper. But without reliable orbital propellant transfer, none of it functions. The architecture collapses at step 2. SpaceX has never demonstrated this at operational scale. In March 2024's Flight 3, they transferred an undisclosed amount of liquid oxygen between 2 internal tanks on a single vehicle. A controlled test, not ship-to-ship. Full in-orbit validation between 2 separate spacecraft has not happened yet. NASA has been waiting years for this demonstration. It remains the largest open technical question in the entire Artemis program. And right now, at Starbase, the hardware that might answer it is being built. Starpipe Florida. The full picture of what's being built. Step back for a moment, because when you put all the pieces together, the pipeline, the pads, the manufacturing, the scale of what SpaceX is constructing becomes genuinely staggering. Start with the fuel problem. A single Starship launch consumes the equivalent of roughly 230 tanker trucks worth of propellant and commodities. Liquid methane, liquid oxygen, helium for pressurization, water for the deluge system. At 45 launches per year from one site, that's over 10,000 tanker truck deliveries annually, before counting hardware, spare parts, or personnel. The roads physically cannot scale to that volume. The logistics break down long before the rockets do. So SpaceX is building a pipeline. They're calling it Starpipe, a dedicated underground natural gas line running from the port of Brownsville directly to Starbase. Gas arrives by ship, feeds through the pipeline underground, and gets liquefied on-site into launch-ready methane. No truck convoys, no road congestion, no supply bottleneck, a continuous underground flow of propellant feeding, a continuous cadence of launches. You don't build permanent underground energy infrastructure for a program you're uncertain about. Starpipe exists because SpaceX is planning for something that looks less like a space program and more like an industrial operation. Now look at what's rising in Florida. At Kennedy Space Center, Pad 39A is effectively complete. Heavy construction done. Finishing work underway. From the air, it looks closer to operational every week. At SLC 37, the first Mechazilla tower is already stacked to 2 segments. The previous tower at Pad 2 in Texas took 43 days to fully stack. On that timeline, Another complete catch tower could be standing in Florida by end of July. Across the SLC-37 ground level, foundation pedestals for a large propellant tank farm are being placed. Concrete is being poured. A site that looked like an empty lot months ago is now unmistakably a launch complex under construction. This week, the chopsticks, the mechanical catch arms that retrieve returning Starship boosters, were transported from Roberts Road to SLC-37. The catch hardware is on site. At Roberts Road itself, the new Giga Bay manufacturing facility is nearly complete, almost entirely clad. Giant bay door openings fully visible. Seen from the air, full-size dump trucks parked around the perimeter look like scale models against the building. This is one of the largest structures SpaceX has ever built, and it exists for one purpose: to manufacture Starships faster than rockets have ever been manufactured before. SpaceX isn't building capacity for a moon mission. They're building capacity for a moon program. That distinction is everything. Flight 13, the launch that has to prove it. All of this infrastructure, all of this investment, all of these numbers, none of it means anything until Starship proves it can fly on schedule, consistently, and come back intact. That proof starts with Flight 13. Ship 40 rolled to the Massey's test stand the night of June 23rd to 24th. All 6 Raptor 3 engines installed. 3 sea level, 3 vacuum, every engine in place. The campaign runs in 2 stages. First, a spin prime, turbo pumps spun up without ignition to verify propellant flow through every line and valve. Then the main event, a full 60-second static fire. 60 seconds of all 6 engines at full thrust, anchored to the stand, every sensor logging every data point. Past the static fire, Ship 40 rolls back for final checkouts and becomes flight ready. On the booster side, Booster 20 needs its own static fire at Pad 2. Once both vehicles clear, the countdown to Flight 13 becomes a matter of weeks, not months. Flight 12 ran roughly 5 weeks from successful static fire to launch, but that was version 3 hardware making its debut on a brand new pad, with multiple rework cycles. The unknowns were stacked. Flight 13 has none of that. The pad is proven. The hardware is understood. A tight timeline puts Flight 13 in early to mid-July, consistent with what SpaceX President Gwynne Shotwell stated publicly about a monthly cadence through the rest of 2026. Flight 13's primary objective isn't any single technical milestone, it's reliability. Demonstrating that Starship launches on schedule and returns safely. Not as an event, but as a procedure. 15 tanker flights only work when each one is unremarkable. And unremarkable only comes from doing it over and over until routine is the only word left to describe it. The real competition, and why the math only moves one way. Here's the twist the critics never anticipated. When NASA selected SpaceX's HLS proposal over Blue Origin in 2021, it triggered a legal challenge, congressional hearings, and years of public controversy. Blue Origin's core argument: 15 launches, too risky, too complex, too dependent on unproven technology. They weren't entirely wrong about the technical difficulty. But look at where things stand today. Blue Origin's Blue Moon lander also requires multiple New Glenn refueling launches. They just don't lead with that number. At roughly $80 million per New Glenn flight and a projected Artemis 5 mission cost of $3.4 billion, delivering 20 tons to the surface, the economics don't hold up against SpaceX's model at any cost scenario. And here's what the critics still haven't absorbed. The more Starship flies, the cheaper each flight gets. The cheaper each flight gets, the stronger SpaceX's position becomes. The stronger their position, the more missions they win. The more missions they win, the more they fly. It's a cost reduction flywheel, and it's already in motion. The real question was never whether 15 launches is too many. The real question is, what happens when SpaceX reduces that to 10, or when per-flight cost drops below $5 million? At that point, the moon stops being an expensive destination and starts looking like a scheduled service. And Mars transitions from long-term ambition to medium-term engineering problem. But before any of that happens, one capability has to be proven. The hardware on that Starbase nose cone is pointing directly at it. Orbital propellant transfer, the final gate. Does SpaceX demonstrate it cleanly, or does this become the bottleneck that compresses the entire Artemis timeline? Flight 13 won't answer that question, but it starts the sequence that will. And the answer will determine whether humans stand on the moon before 2030, or watch that decade close without it. The gate is set, the hardware is moving, the math already works. If this broke it down clearly for you, like, subscribe, and drop your thoughts below. The Space Brief. See you in the next one.